we're going to use list comprehensions to help us write our parser. We were introduced to them earlier, and many computer scientists love list comprehensions because they allow you to state what must be true about a list and let the computer figure out how to get there. So just to remind you a bit of list comprehensions, we use the square bracket to say I'm making a list. But instead of listing all of the elements directly, I have some sort of formula. What I really want is to take all of the elements in 1, 2, 3, 4, 5. Let's call each of those x. I want my new list to be all of those squared. So x times x. So 1, 2, 3, 4, 5 should give us 1, 4, 9, 16, 25. And down here in the output it does. In list comprehensions, we can also put little clauses or guards to only take some of the input list. Let's say that I only want to square those numbers that are odd. Well, I write everything just the same as before, but at the end, I put in this little guard that says only yield this element if x modulo 2 is 1. That is, if x is odd, if the remainder when dividing x by 2 is 1. So this second list only contains 1, 9, and 25 for the numbers 1, 3, and 5. So we had our little refresher on list comprehensions, and now we want to parse a string according to a grammar. So let's say our grammar would look like this if we wrote it down on a piece of paper. We need to encode it in Python. Well, here's one way to do it. I'm going to take all of the left-hand sides of all of the rules and write them out as the first part of a tuple. And then all of the right-hand sides, like open, p, close, become elements of a list. Open, p, close. So here my grammar had 3 rules, and here my grammar is a list of 3 elements. This second element corresponds to my second grammar rule. P on the left-hand side, P in the 0th position, open P close on the right-hand side, open P close in a list on the first position. I'm going to need to do the same thing with parser states. Here's how I might draw one in color on a piece of paper, and here's how I'm going to encode it in Python. This is just one way to do it. We could pick a different way, but this is going to simplify our implementation. There are really 4 parts of our parsing state. The left-hand side non-terminal, some list of terminals and non-terminals before the dot, some list after, and J. The right arrow, the dot, and the word from, we always have to write them, so I don't need to store them. I'm not going to write down from every time. We'll just remember it. So I'm just going to make my state a 4 tuple, but instead of it being 1, 2, 3, 4, 1 will be the non-terminal on the left. This will be a list of A and B, and there might be more things here, or there might be nothing, at which point it's the empty list. 3 will be a list of things after the dot. There might be more things there, or again, there might be nothing, at which point probably we want to use reduction. And then J will just be some integer.